So attempt this first. Make sure you pause the video and attempt this problem. It asks, to examine the following graphs, identify the interval of the solid portion. So here I have the solid portion, here the solid portion of the graph. Solid portion of the graph, we can trace it, solid portion of the graph. This one is actually highlighted from 0 to pi. This one goes, I can write this a little more clearly, right? This one goes, so graph here, y equals sine of x, or sine of theta. The solid portion is negative pi halves, less than or equal to theta, less than or equal to pi halves. For the graph of y equals tan of theta, we have the solid portion of the graph of negative pi halves, less than or equal to theta, less than or equal to pi halves. And for the graph of cosine of theta, remember that's our learning goal in this video. Let's understand the inverses of these three functions. The solid portion of the graph goes from 0, less than or equal to theta, less than or equal to pi. So what appears to be true about the function? Notice that on each function, each input maps to exactly one output, right? You might consider this as the horizontal line test. If you were to take a horizontal line and move it across these functions, every time you move, there's exactly one y value for every x value. We get that nice one-to-one and onto characteristic of our graphical representations. So now, when we examine the definitions of our inverse functions, it shouldn't be surprising to note that the domain, right, of sine inverse, so this is a definition now, right? Sine inverse of x is the angle between negative pi halves and pi halves whose sine is x. So what does that really mean? Let's break that down before looking at the other two definitions. Essentially what that means in this teaching problem, you can think about it graphically, you can think about it in terms of function notation, but you can also think about it using the unit circle. So if we have our unit circle, and I'll draw a grid on this one, sine inverse is the angle whose sine is x. So in this case, if we just take one of the most standard angles, let's take pi fourths. I know the ordered pair on the unit circle when r equals 1. This ordered pair is square root 2 over 2 and square root 2 over 2. Okay. Angle between negative pi halves and pi halves. So if we were to ask, for example, what is the inverse sine, written this way, inverse sine of square root 2 over 2, well, it's equal to pi fourths, because this is the angle such that sine of pi fourths equals square root 2 over 2. Notice what happened. Notice this difference. I won't do the other two examples. I'll leave those for you to consider as examples. But look at this. When we think about the reverse process of our sine and our cosine, notice that the input for one function, right, the reverse process, we'll do this next. When we think about this original diagram that I drew, right, if we have f of theta equals sine of theta, our theta is our input, or our y is our output, okay? So we have in, we have out. One thing that we've been emphasizing in this whole unit is that theta is a measure of an angle, And my output is a length, and specifically it's the vertical length or distance, because it could be negative. So I'm going to say vertical distance from point on circle corresponding to the angle from my input to the x-axis, right? Remember that when we've been dealing with the sine function, we've been thinking about give a particular angle, get a particular length, right? Let's do another easy one for an example. Let's do these two as an example, right? So in this case we have pi fourths, and in this case we have pi halves. So I know that this ordered pair, we're really just looking for sine of pi fourths is square root 2 over 2, the y value or length, distance of that coordinate, whereas the sine of pi halves is 1, this length here, which happens to also be the radius. Well, the inverse, right, if we were to go back to method 1 from earlier in the warm-up, and we take each of these in turn, let's look at A. So we have sine of pi fourths is square root 2 over 2. So now if we take inverse sine of pi fourths, which equals inverse sine of square root 2 over 2 to maintain that equivalence identity, we get pi fourths equals sine inverse of square root 2 over 2. Notice, the input is a distance, my output is an angle. Right? We reverse the process of sine. So when we think about that, right, reversing the process of sine, F inverse or sine inverse, right, our input is a length, our output is an angle. I'm going to rephrase this as distance, because it can be negative. All right. With those examples in mind, the important thing to note is that we have definitions of our 3 inverse functions: sine inverse, tan inverse, the angle whose tangent is x; cosine inverse, the angle whose cosine is x. And we also have the notation, right? So alternative notation here, sine inverse of y. So now we can also use the notation here. I'll add it just below. We can do tan inverse of x equals y, or arctan x equals y. Likewise, cosine inverse and arc cosine